Welcome to another video in the series of data analytics using Microsoft Excel. In our previous video, we saw how we can fix a frequency polygon to a histogram. The image that you see on the left hand side where I am moving my mouse pointer. Whereas I also explained towards the end of the video how can we also fit a bell curve in the same histogram so that we will be able to graphically understand whether our underlying data follows normal distribution or not. A bell curve is otherwise a standard normal distribution curve, what you see on the right hand side. So this bell curve is a standard normal distribution bell curve. So how can we fit this bell curve on our existing data and see whether our existing data more or less fits a normal distribution. So this is what we call by fitting a bell curve on a histogram. This is what we are going to understand in this video. Let's get into the video. As I was explaining in the introduction of this video, let us understand how we can fit a normal curve or what we call it as a bell curve on this histogram to see whether this histogram fits into a normal distribution curve. So this is one way of graphically analyzing whether our data follows normal distribution or not. So there are two more methods of graphically analyzing whether our data follows normal distribution or not, which is a QQ plot and a PP plot, quartile plot, and probability plot, which we will be explaining in our upcoming videos. In this video, we will see how we can fit a normal distribution curve, otherwise called a bell curve, on a histogram to see whether our data follows normal distribution. In order to fit this, we need to add two more data columns. One of the data column will be called X and the other one will be called Y. So we will now create X and Y. Now how are we going to create this X and Y? I have already calculated the descriptive statistics for this particular data, and that descriptive statistics is our max, min, average and standard deviation. The maximum value, minimum value, average value and standard deviation. Also we have used the data analysis plugin or add-in to create bin wise data points, and based on this the histogram is drawn. All this is covered in our previous video, which is data analysis video number 18. So I can also share you the link of that video in the description. So once we have all this information calculated and a histogram drawn up to this stage, now we can create the required information or data to plot the bell curve. The first information that we need is what is the minimum value of our data set. So let's say the minimum value is 72 because it's 72.41. So we can take 72 as our minimum value. And what is our maximum value? Our maximum value is 125.84. So we can drag this for 126. So we are creating numbers from the minimum value to the maximum value. So if you see here, I have generated values in X column from 72 to 126. Why 72? Because in my given data set, 72.4 is the minimum value. Similarly, in my given data set, 125.8 is the maximum value. Okay, now what are we going to do? Now we are going to find out the probability function. What is the chances of a value 72 appearing in a data which is if normally distributed with an average of 99.79 and with a standard deviation of 9.30. If a data is normally distributed with this average and standard deviation, what is the probability of you getting a value called 72? So to understand this, there is an Excel function called norm.dist. So the Excel function is norm.dist. So the syntax of this norm.dist will be, you need to select your data. So for us the data is in column E22. So we are calculating this in F22. So the actual data is in E22. So E22 comma average 99.79 comma standard deviation 9.30. So as we are going to use this average and standard deviation throughout the entire list of data points that we have generated, I am going to freeze this cell by pressing F4. So by pressing F4, we will be able to add a dollar symbol before and after the alphabet and then numeric, so that F5, the cell in which we have the average, so that cell get freezed. So similarly, I freeze my standard deviation cell. And finally, the last information that we need to give in this function is Do you need a cumulative probability or you just need the normal distribution probability value? So if I put 0 and close this, it only gives me the probability of getting 72 as a data point for a distribution which is normally distributed with an average of 99.79 and standard deviation of 9.30. So the probability to get that kind of data is 0.000494. Okay. Now, once you use this function, the next thing that you need to do is to get a bell curve fitted to the histogram. You need to multiply this probability with the total number of data points. In this case, it is 150. Again, multiplied by your bin size. In this case, our bin size is 5. So, probability distribution function multiplied by total number of data points. In this example, it is 150 multiplied by 5, which is nothing but the bin size in this example. Now you can copy and paste this for all your individual data points. So now we already have a histogram for the underlying data, for which we have the midpoint and the corresponding count of values, based on which the histogram is already drawn. As I told how to draw this, we have already discussed this in our previous video. Now we are going to add the bell curve to this. So in order to add the bell curve to this, you can select this particular chart and now you can click on chart design. As you click on chart design, there is an option to select data. So if you click select data, this panel or the small window opens up where you will be able to add another series to this particular data. So how are we going to add this? We are going to click on add. You will have series X value. So in the series X value, we are going to select this data where we have the minimum to maximum data point. And similarly, in the series Y value, we are going to delete this and we are going to add the probability function multiplied by total number of data points multiplied by bin size, what we have in column Y. So as we select these two values and then click OK and then click OK, we will be able to fit a bell curve, right? We will be able to fit a bell curve. So I'm going to click on format data series so that we would be able to make this bell curve more visible. So let me give a green color font to this, and let me also increase the width of the line so that it becomes easy for us to visualize. So for a data with an average of 99.79 and with a standard deviation of 9.30, the bell curve will be something like this green color bell curve that you are looking at. However, for our particular data, we have drawn a histogram and tried to fit a frequency polygon which is in red color. And actually, if this data is perfect normal distribution, this red color line will actually overlap with this green color line, but that is theoretical. You may not be able to get a perfect normal distribution when you collect random samples from a live process, right? Perfect normal distribution is not possible. But how much this red color line is more or less, or the histogram is more or less fitting with this green color line, will tell you what are the chances of this data being normally distributed. So here, based on our experience, what we can say is approximately the underlying data, which is nothing but your blue color histogram, more or less follows normal distribution. It's not a standard perfect normal distribution, but majority of the data points are behaving as per the normal distribution curve requirements, right? So as we saw in the beginning, it's a graphical way of understanding whether the data is normally distributed or not. However, if you want a statistical way of understanding whether this data is normally distributed or not, so there are many statistical tests available like Anderson-Darling test, Ryan-Joyner test, Kolmogorov-Smirnov test, Shapiro-Wilk test. So there are many tests available. Maybe on another playlist I will try and explain all those statistical tests, but as a graphical test, this is one way of checking this. This is how you do it in Excel. Now the same data I'm going to copy and paste it in Minitab so that we will be able to see how the Minitab graph looks like. So let me copy this data and paste it in Minitab. Now I click on graph, I go to histogram. In histogram, I select this particular option, and this particular option is histogram with the bell curve fitted to it, and see whether the data follows bell curve distribution. So I select this data and then I click OK. You will be able to see a histogram with a bell curve fitted to it. So let's copy this. You might find some small minor differences in how the graph looks like. but still more or less how, because there's minor differences because of the kind of bin definitions that we have given what should be the bin width, where it should start. So based on that, there will be some kind of minor difference, but more or less the graph will look somewhat similar. So for all those people who have done this histogram with a bell curve fitted to it in Minitab but not sure how to do it in Excel, I hope this video would have been helpful for you to understand this. So in our next video, we will explain you how the same normality, whether the data is normally distributed or not, how it can be understood using a plot called QQ plot. And followed to that, we will also upload another video on how you can check whether the data is following normal distribution or not using a different type of a plot called PP plot, which is probability plot. QQ plot stands for quantile plot, and PP stands for probability plot. Okay, so friends, I hope this way of fitting a bell curve to a normally distributed or fitting a bell curve on an underlying data and see whether that underlying data is normally distributed or not. I hope you are able to understand this. Thanks for your time. So please subscribe our channel and follow our channel for more videos on how to do data analysis and data visualization using Microsoft Excel. Thanks for your time. See you in another video.